Hello dear viewers, you are most welcome. Today we are going to very much or understand more about vector geometry as our subtopic tonight. So welcome to this video and to the channel. Please, if you are new to this channel, this is O'Level 2 Math channel, and please kindly subscribe, turn on the notification button so that you are notified whenever I upload any video, like and share. So now let us dive into the video. So today we are to understand more about vector geometry, and we are saying that vector geometry involves the use of geometric figures to determine or express some vectors in terms of other given vectors. So we are going to have examples that we are going to use to understand the concept very well. Let's begin with example 1. They are saying that in the diagram, X, Y, and Z are the midpoints of the sides of the triangle ABC. So the X, the Y, and the Z are the midpoints of the sides of the triangle here, as you can see. Then the question is saying, or a statement which is in the form of a question, use vectors to show that AX, Y, Z is a parallelogram. So they want us to show that AX, Y, Z is a parallelogram. Let's have now the response and see how we could answer or respond to this question. Let us have our response. We are given a figure. Let us have it here. So now from this figure we have vector SC is equal to the vector AB plus vector BC. So that is what we have to know by taking the direction that if you are getting vector SC from here to here under this direction, the same as taking the direction of this, also we add it to the direction of this. What it means, remember they want us to show that the line XY and the line AZ are parallel and also ZY are parallel. This implies that we are going to get the vector XY, which is now equal to, so from this diagram, the vector XY, it is taking this direction here. It is the same as moving from X to A in that direction, plus from A to C in this direction, and then from there we move from C to Y in that direction. So it implies that the vector XY equals to the vector XA plus the vector AC plus the vector CY. Or we have another way we can get still that vector, or still we can use the other route, that vector XY, the same as moving from X to B in that direction. So we have vector XB plus the vector BY in this direction. So plus vector BY. So I see that we can use the second one. So because the second one is short, we have only two items that we need to determine. That means we could easily get the vector XY with ease. So now it implies that our vector XY equals to, so vector XB is the same as the half vector AB. Why am I saying a half? Because they said in the question that X is the midpoint of the line AB. Means that when I'm expressing the vector XB is a half of vector AB plus the vector BY, but BY is a half the vector BC, implying that if I simplify this, I can see a half is common. Let me pull it out into, I'm going to have the vector AB plus the vector BC under the brackets, implying that vector XY simply equals to the half vector AB plus vector BC. So this becomes the expression for our vector XY. We need to go ahead and determine also the vector AZ, and we check whether it is parallel to this vector we have already obtained, which is vector XY. So now, as you proceed, the vector AZ is the same as the half vector AC. So we are saying a half vector AC because they say that the points X, Y, Z are the midpoints of these lines of the triangle. But now vector AC is here, as we can see in here. So let us substitute it in that expression. It means that vector AZ equals to a half our vector AC, which is the same as a half vector AB plus vector BC. C. Therefore, this becomes our expression for vector AZ. Now, as we compare these two, let's try to compare them. As we compare these two, the vector AZ in these boxes, we see that we have the same thing, implying that these two vectors are equal. Therefore, by responding to the question here, which they want us to show whether the figure A, X, Y, Z is a parallelogram, it means that we are going to deduce and say that therefore, the figure A, X, Y, Z is a parallelogram since vector XY is parallel to vector AZ, in that vector XY equals to vector AZ and are equal. Also, the vector AX is parallel to vector ZY. So if now these vectors are parallel, it implies that even the others are parallel. Therefore, the figure AXYZ is a parallelogram. Let's have another example. Example 2. You're having our diagram there, as you can see, and here is the question. They said in the diagram above, ABCD is a rhombus, ABCD is a rhombus, where vector AB is symbolically represented as this, and vector AD is that. Also, trace vector BY is equal to the vector DB, and vector CZ equals to vector XC. We have Roman number 1, find in terms of A, of vector A and B, part A, the vector SC, part B, vector XY, and part C, vector XZ. Then Roman number 2, show that the line BC and YZ are parallel. So now let us have our response. So response to number 2, or question number 2. Remember the diagram is here. Let me bring it, this point. So it is there. We can see that we are given that trace vector BY equals to vector DB. That trace vector BY equals to vector DB. And still vector CZ equals to vector XC. So it said vector CZ equals to the vector XC. And also that vector AB equals to that vector AB equals to A, and the vector AD is given by that. So we have Roman number 1. We have determined in terms of vector AB, the vector AC. So Roman number 1, we have to get vector AC. So equals to, from our diagram here, vector SC is this from A to Z in that direction, and they want us to get it. Alright. Vector SC from this diagram, the same as moving from A to B in that direction, and then from B to C in this direction. So it means that vector SC equals to the vector AB plus vector BC. But since the figure ABCD is a rhombus, so we can say that but vector BC equals to the vector AD, since the figure is a rhombus. So this implies that our vector SC equals to the vector AB, which is the A, plus the vector BC, which is equal to vector AD, so plus a B, implying that our vector SC equals to the A, vector A plus vector B. So this becomes our expression for that Roman number 1 part A. Then Roman number 1 part B, we are determining vector XY. We can have Roman number 2, we are determining vector XY. So from see the diagram here, let me first erase this. From the diagram, we want to get the vector XY. So from here to there in this direction, first and foremost, we need to get the vector. So vector XY is same as having the vector XB plus vector BY. So from this expression here, we can get vector BY if we use it. So we can first go ahead and get vector BY. So let us determine vector BY. So from trace vector BY being equal to the vector DB, it implies that our vector BY equals to a half vector DB. But now what is vector DB? Let us try to get vector DB. But vector DB from the diagram here, vector DB from D to B is the same as getting vector DA plus vector AB. So vector dA is the same as the negative of vector AD, the reverse of direction has happened, plus the vector AB. So now let us substitute in. Vector AD is given by B. That means you have negative B plus the vector AB, which is A, implying that vector dB equals to the A minus a B. So this is vector D dB, implying that our vector by equals to a half vector A minus B. So for now we have got vector by. Let us go ahead and get vector xb. So vector xb, still from the diagram, let me bring it here. From the diagram here, we can see that vector xb, the same as vector xa plus vector ab. So it means that vector xb equals to vector xa plus the vector ab. Let me take away this. So now let us simplify this. This is equal to our vector xa is the same as the negative a half of vector sc, because there has been a reverse in direction. As we can see, remember we got the vector sc which was in taking this direction, and for us we are getting just vector xc b which is taking this direction, and we are saying that this point x is the midpoint of the line AC. So that's why we are having the half vector SC. The negative is coming as a result of the reverse in direction. So as we proceed, this is the same as having the negative a half. Vector SC is here. We already got it. Vector SC is the A plus B. So now we have got a vector XB and vector BY. We can go ahead and get vector XY. So as we proceed, we assign that vector xy, which is equal to the vector xb plus the vector by. So, but vector by, we have got it. It is a half a minus b. Also, vector xb equals to the negative a half vector a plus b. So this implies that our vector xy equals to, so the xb is negative a half into a plus b plus the vector by, which is a half into a minus a b. So let us simplify the expression on the right hand side. So here we have negative a out of 2 minus divided by 2 plus vector a divided by 2 minus vector b divided by 2. So we see that this and this, they cancel out, implying that we are remaining with negative vector b divided by 2 minus vector b divided by 2. As we simplify, this is the same as negative vector b. Therefore, the vector xy in terms of vector a and b equals negative vector b. So this is the expression we are getting for this case. We are now going to part C of Roman number 1. They want us to get vector xz. So let us proceed. The vector xz equals to, so still let me bring back the diagram. They want us to get vector xz from here to there in this direction. That means we are going to add the vector xc plus vector cz. So it means that vector xz equals to vector xc plus the vector cz. But from the question, they gave us that vector cz equals to vector xc. So we can say that, but vector cz equals to vector xc. Therefore, it means that vector xz equals to vector xc plus vector xc, means that we have 2 vector xc. But now what is vector xc? Vector xc, since x is the midpoint of the line AC, it implies that we are going to have twice into the a half vector AC. But vector AC equals to, so we can cross check from earlier on, vector AC. Vector AC is here, is a plus b. So vector AC equals to the a plus b, implying that our vector xz equals to 2 multiplied by a half into vector a plus vector b. So this is the same as having vector A plus vector B. Therefore, vector xz equals to vector A plus B. So this becomes our expression for that Roman number 1, part C. The question is still proceeding. We have Roman number 2. Show that the line BC and line YZ are parallel. So we need to show that the line BC and the line YZ, so that they are parallel. It's what we have to show. So now let us proceed to that. Our part B, we are required to show that the line BC is parallel to the line YZ, implying that we are going to get vector BC and vector YZ and compare them. If they are parallel, then we shall deduce that those lines are also parallel. Let's have our diagram here. So let us now begin by getting vector BC. Vector BC from our drawing equals to, since this is a rhombus, vector BC is same as the vector AD, but vector AD equals to vector B, implying that our vector BC equals to the B, vector B. So we have so far got the vector BC. Let us go ahead and get vector YZ. So vector YZ equals to vector YZ, the same as moving from Y to B in this direction, then from B to C in that direction, and also from C to Z. So they want us to get vector YZ, getting vector YB plus the vector BC plus the vector CZ. So this is the same as, so now what is vector YB? But we got vector BY. I remember we got vector BY. It is here, vector BY. Vector BY is a half vector A minus B. So let us take a note of that. So this is the same as negative vector BY plus the vector BC, which we have it here, plus the vector CZ. But from the question, as if we have vector CZ, vector CZ is same as vector XC, and we got vector XC in part C of Roman number 1. So now this is the same as we said we have a negative a half vector A minus vector B plus vector BC, which is simply B, plus vector CZ. Let us check whether we got vector CZ. Vector CZ is same as vector XC, but our vector XC is a half vector SC, and our vector SC is A plus B. So it implies that our vector CZ is now is a half vector AC. So as we simplify, this is same as having negative a half of vector A minus vector B plus vector B plus a half vector AC is the same as vector A plus vector B. Let's just open the brackets and see what we shall get. So as we proceed with simplifying this, we are having the vector YZ being equal to the negative vector A out of 2 plus vector B out of 2 plus vector B plus vector A divided by 2 plus vector B divided by 2. We can see that this and this, they cancel out, and we remain with our vector YZ being equal to the vector B divided by 2 plus the vector B plus the vector B divided by 2. As we simplify, this is the same as having vector B plus vector B. As we add them, we are having 2 vector B. Therefore, the vector YZ equals to twice vector B. Let us now check. That means vector YZ is given by this expression. Let us now compare these two, the vector BC and vector YZ. We see that these two vectors are parallel. How? We can say that vector YZ equals to twice vector BC, because vector BC equals to B, implying that if these vectors are parallel, also the line BC and YZ are parallel. We can conclude and say that therefore the line BC and line YZ are parallel, since vectors YZ and BC are also parallel, i.e. we have seen that vector YZ equals to twice vector BC. So let us now have the exercise. The exercise is here. You can see. You try out this exercise and you drop the answers in the comment section. And please endeavor to subscribe to the channel. Thanks for watching. See you again. Goodbye.